The James Webb Telescope was developed to cater to any purpose. One of the most important purposes is to search for exoplanets that are capable of being habitable and may have alien civilizations on them. The search for aliens has been on for a long time, but scientists discovered one of the nearest Earth-like planets to hold the key to burning questions. Stay until the end to find out what was discovered on Proxima b. Welcome to our channel where we provide you with facts related to space. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so that you may get all of our updates. Proxima Centauri b is an exoplanet orbiting the star closest to Earth, and it has captivated scientists with its potential similarities to our own world. Located just over 4 light-years away, this planet represents a tantalizing opportunity to explore what lies beyond the familiar. Its proximity in cosmic terms offers a unique chance to study a potentially habitable world outside our solar system. The scientific community has long been fascinated by the idea of finding planets that could sustain life. And discoveries like Proxima b have reignited that passion. Yet what's truly intriguing is that some exoplanets might not only resemble Earth, but actually offer better conditions for life. This notion, supported by prominent thinkers like theoretical physicist Michio Kaku, suggests that we should not limit our search to Earth-like planets, but also consider the possibility of superhabitable worlds, planets that might offer more favorable climates, richer ecosystems, and overall better living conditions than our own. Such planets could feature abundant water, fewer deserts, moderate and stable temperatures, and even greater expanses of land, making them prime candidates for human colonization in the far future. For decades, astronomers have sought a terrestrial twin, a planet as close to Earth as possible in terms of size, composition, and distance from its star. This quest has been considered the holy grail of exoplanetary science. Thanks to technological advancements in telescopes and detection methods, researchers have made great strides toward identifying such planets. Michio Kaku, co-founder of string field theory and an influential voice in modern physics, has often stated that the long-term survival of humanity may depend on our ability to become a multi-planet species. He envisions a future where humans not only inhabit Earth but also settle on other worlds, thus ensuring the continuity of civilization even in the face of global catastrophes. Earth, while our cradle, is not immune to existential threats such as asteroid impacts, supervolcano eruptions, global pandemics, and even climate-driven glaciation periods. More dramatically, the Sun itself will eventually render the planet uninhabitable when it expands into a red giant in about 5 billion years. In light of these inevitabilities, the search for a new planetary home is not just visionary, it's essential. However, focusing solely on finding planets that are Earth-like may be limiting. In fact, some researchers believe we should widen our scope and look for planets that are potentially more habitable than Earth. The idea that a planet could surpass Earth's inhabitability challenges our assumptions about life and invites a broader, more nuanced exploration of the universe. In 2014, scientists Renee Heller and John Armstrong proposed that a planet's habitability is determined by more than just its location in the Goldilocks zone, the range of distances from a star where liquid water could exist. While this habitable zone is still a key criterion, Heller and Armstrong argue that a planet's ability to support life involves a wide range of variables, including atmospheric composition, magnetic field strength, geological activity, and the nature of its host star. Water remains a central factor in this equation, as it is essential for all known forms of life, but it is no longer the sole consideration. Notably, the search for life-supporting planets has already shown us that habitability might arise under very different conditions than those found on Earth. Take for example Europa, one of Jupiter's moons. Despite lying far outside the Sun's habitable zone, Europa harbors a vast subsurface ocean kept warm by tidal heating from Jupiter's gravitational pull. This suggests that life could exist in places we might not expect and that our geocentric model of habitability needs re-evaluation. The focus on Earth analogs may in fact cause us to overlook other viable, and perhaps superior, environments for life. A shift in perspective is needed, one that emphasizes biological potential over Earth-based assumptions. The idea of superhabitable planets proposes that some worlds may offer conditions even more conducive to life than our own. Heller and Armstrong advocated for the creation of detailed exoplanet profiles that consider factors such as the planet's size, age, host star type, orbital characteristics, and geological stability. Traditionally, our search has concentrated on yellow dwarf stars like our Sun, but this narrow focus may be misplaced. Researchers are increasingly turning their attention to red and orange dwarf stars. Orange dwarfs, in particular, are cooler and smaller than the Sun, but have much longer lifespans, ranging from 20 to 70 billion years, compared to the Sun's 10 billion year life cycle. This prolonged stability could give life more time to evolve and flourish. On Earth, complex life took approximately 3.5 billion years to emerge. So, a planet orbiting an older, more stable star could be far ahead of us in terms of biological development. However, there are limitations to age as well. If a planet is too old, it may lose internal heat, leading to reduced tectonic activity and the disappearance of a protective magnetic field. Without such a field, the planet becomes vulnerable to cosmic and solar radiation, which can be lethal to complex life. Heller and Armstrong posited that the optimal age range for a superhabitable planet is between 5 and 8 billion years, older than Earth, which is about 4.5 billion years old, but still young enough to retain essential geophysical characteristics. In addition to age, a planet's size and mass are critical factors. A planet that is 10% larger than Earth would provide more surface area and could support a denser, more stable atmosphere. Similarly, a planet with 50% more mass than Earth would experience longer radioactive decay, sustaining internal heat and maintaining a protective magnetic field for extended periods. There may be downsides to such conditions. For instance, higher gravity might make human movement and construction more difficult. However, the advantages could easily outweigh the challenges. A stronger magnetic field, a stable climate, and richer biodiversity would create a nurturing environment for both native life and human settlers. Warmer planets might also prove more fertile than Earth. Here on our planet, the most biologically diverse regions are tropical rainforests, ecosystems characterized by warmth and moisture. Slightly higher average temperatures, when combined with adequate precipitation, could lead to even richer ecosystems. Of course, such worlds would need to avoid becoming too hot or too dry, as arid deserts are typically less hospitable to life. Geography also plays a key role in supporting biodiversity. Planets with similar land-to-water ratios as Earth but with more fragmented land masses like archipelagos and smaller continents could offer more shallow coastal areas. These regions on Earth are hot spots for marine life due to the availability of sunlight and nutrients. Thus, a world with more coastal zones and fewer deep oceans might support an even broader range of species. The challenges of detecting and studying these potentially ideal worlds are considerable, but researchers remain optimistic. Some of the most promising candidates for superhabitable planets are already under investigation, including those in the Alpha Centauri system. Though none of these planets have yet been confirmed to be habitable, their proximity makes them exciting targets for future exploration. Proxima Centauri, the closest star to our solar system, is a red dwarf located just 4.2 light-years away. It hosts several planets, including Proxima Centauri b, which lies within the star's habitable zone. Because of its location, liquid water could exist on its surface, at least in theory. However, Proxima b faces significant challenges that cast doubt on its habitability. It is likely tidally locked, meaning one side perpetually faces the star while the other remains in darkness. Additionally, red dwarfs like Proxima Centauri are prone to violent stellar flares and emit high levels of ultraviolet radiation, which could strip away a planet's atmosphere over time. These issues make the presence of life on Proxima b uncertain, but its nearness to Earth ensures it remains one of the most studied exoplanets in the galaxy. Currently, more than 5,000 exoplanets have been confirmed, and thousands more await verification. Among these, scientists have identified 24 candidates that may be more habitable than Earth. One notable example is KOI 5715.01, a planet located approximately 700 light-years away. This world orbits a yellow dwarf star and is estimated to be about 6.5 billion years old. Its surface temperature hovers around 80 degrees Fahrenheit, and its size ranges between 0.72 and 1.29 times that of Earth. Though this planet is far from reach with current technology, future space missions, especially those utilizing powerful instruments like the James Webb Space Telescope, may allow us to study such planets in greater detail. By analyzing their atmospheres, we could potentially detect biosignatures or signs of biological activity. In the end, the search for extremely habitable planets challenges us to expand our definitions and expectations of what it means for a world to be life-friendly. As our technology improves and our understanding of planetary science deepens, we may come to realize that Earth is not the gold standard of habitability. Worlds with more water, longer-lasting atmospheres, warmer climates, and stable geological activity might offer superior conditions for life. Exploring these planets could change everything we know about the origins, evolution, and potential of life in the universe. Future missions and ongoing discoveries will not only help us answer the age-old question, "Are we alone?" but may also show us where humanity might one day thrive beyond Earth. As the search for superhabitable planets continues to gain momentum, our understanding of planetary diversity is expanding far beyond the initial assumptions rooted in Earth's particular conditions. The discovery of exoplanets in varied environments has prompted scientists to reframe the criteria for life-supporting worlds. Instead of strictly adhering to Earth's blueprint, researchers are now examining a broader range of factors, including atmospheric chemistry, rotation rate, axial tilt, orbital eccentricity, and cloud cover, all of which can drastically affect a planet's climate and its capacity to sustain life. For instance, a thicker atmosphere with more greenhouse gases might help a distant planet maintain liquid water even if it orbits farther from its star than Earth does. Conversely, a planet closer to its star could remain temperate if its albedo, its reflectivity, is high due to cloud coverage or ice. Astrobiologists are also considering planetary systems with multiple habitable zone planets where the exchange of organic materials via meteorites might boost the probability of life taking root. This idea, called panspermia, suggests that life or its building blocks could potentially spread from one planet to another within a system, especially if the planets are relatively close to one another. Such interplanetary seeding could accelerate biological development,